Hello students, in today's lecture we are going to study the Bessel function of first kind, and it is usually represented by Jnx. Clear? So in our previous lecture we discussed that the Bessel equation is Bessel's equation is given as x square d square y upon dx square plus x into dy upon dx plus x square minus n square into y, which is equal to 0. This is the Bessel's equation, and the solution of this equation we found, you can see it in our previous lecture. The solution of equation 1 was y equals to a naught into x to the power n into 1 minus 1 upon 4 into n plus 1 into x square plus 1 upon 4 square into 2 factorial into n plus 1 into n plus 2 into x to the power 4 minus the next term, which is 1 upon, and this solution was given for m equals to n. And we discussed in our previous lecture that this solution is called Bessel function of order n, and now we are going to write it in summation form. As you know that there is one thing common, that is a naught x to the power n, and now we are going to write this series in the form of summation. So let's suppose it that y is equal to a naught x to the power n into summation r equals to from 0 up to infinity. So what we are going to write it as that each term, when we apply the summation to the terms, then for each value of r we will get these terms. So when we apply r equals to 0, we should get 1. For r equals to 1, we should get this term, and for r equals to 2, we should get this term, and so on. And also note that here the first term is positive, the next is negative, then positive, then negative, and so on. So first we should write for the term, for the sign term, which is for the first value should be should come to be positive, and the next value should come to be negative. So we can write it as minus 1 to the power r. Clear? So if we put r equals to 0, we get plus 1, and when we put r equals to 1, we get this sign which is negative, and if we put r equals to 2, we get positive. So this minus 1 to the power r gives the signs of each of these terms. Next, what should we write? That here in the numerator you can see that this is x to the power 0. Here we can write x to the power 0, and here x to the power 2, x to the power 4, x to the power 6. Then if I write x to the power 2r, when r equals to 0, then x go to the power 0 goes to 1. So again this for r equals to 0, again we get 1, and when r is equal to 1 we get x square. Clear? And for r is equal to 2 we get x to the power 4. And now for the denominator, so in the denominator, here first we have here 4, or we can write this 4 as 2 square. Let me write it as 2 square here, because here we have 2 square, then 4 to the power 2, or we can write 2 to the power 4. So if we write it as 2 to the power 4, so again it gives the same result. Clear? So if you see here we have 2 square, then in the next term we have 2 to the power 4, and in the next term we have 2 to the power 6, and in the next term we will have 2 to the power 8, and so on. Clear? So for the 2 square, if we write it as 2 to the power 2r. Clear? Let us check it again. When r equals to 0, so this will become plus 1, this will become 1, and this will become again 1. Clear? Because r to the power 0, 2 to the power 2r will give us 2 to the power 0, which is equal to 1. So this again, this whole term for r equals to 0 give us 1, and for r equals to 1 this will become minus 1, and this will become x square, and this will become 2 square. And for the next term, when r equals to 2, this will become positive, this will become x to the power 4, and this will become 2 to the power 4. Clear? So, and up to this term our summation goes according to our choice. Now in the first term we have 0 factorial here in the denominator, because 0 factorial equals to 1, and then here we have 1 factorial, then 2 factorial, 3 factorial, 4 factorial, and so on. So here we can write it as r factorial. Clear? Because here in the denominator we have 0 factorial, in this term we have 1 factorial, 2 factorial, 3 factorial, 4 factorial, and so on. So if we put r equals to 0, this whole term will give us 1, and when r equals to 1, this will give us minus x square divided by 2 square into 1 factorial. Clear? And now for this term, which is n plus 1 into n plus 2, n plus 1 into n plus 3, plus 2 into n plus 3. So we can write it as in this form, like In the first term we have nothing. Here we have n plus 1, n plus 1 times n plus 2, and these terms are increasing by term by term. So we can write it as n plus 1 into, when r equals to 0, this whole term will give us 1. Clear? And similarly for the next term, n plus 2 into n plus 3 dot 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 up to n plus r. So students, now we are reached here that we replaced all these series into a summation form. So now we are going to substitute the value for a naught, which is an arbitrary constant, and this function is incomplete until we do not put the value of a naught. And the value of a naught is where a naught is an arbitrary constant, and it is given as a naught is equal to 1 upon 2 to the power n into gamma n plus 1. This is the value of a naught. So if we substitute this value in the above summation, this will become and remember, if we put this value in the above expression, then this series is called Bessel function, and that is denoted by Jn of x. Clear? So now I am going to represent it by Jn x, and it will become 1 upon 2 to the power n into gamma n plus 1 into x to the power n, and summation minus 1 to the power r, and this will become x to the power 2r divided by 2 to the power 2r into r factorial into n plus 1 times n plus 2 times n plus 3 and so on up to n plus r. Clear? And now we can also take this term, or we can include this term inside the summation. So when this x to the power n is multiplied with this x to the power 2r, so it will become it will become 1 upon 2 to the power n into gamma n plus 1 into summation minus 1 to the power r, and remember that the summation is for r equals to 0 up to infinity, and this will become x to the power, here we have 2 to the power r and 1 here, n here, then it will become n plus 2r divided by, and also students, if we bring this 2 to the power n here, inside the summation. So I am going to write this 2 to the power n here. So it will also become 2 to the power 2r plus n, which is n plus 2r times r factorial into n plus 1 times n plus 2 times n plus 3 times up to n plus r. Clear? Now, also by the properties of gamma function, we know that gamma n plus 1 is equal to n factorial. Clear? N factorial. So I can also include this term inside the summation, so it will become summation from r equals to 0 up to infinity. This will become minus 1 to the power r, and x divided by 2 whole to the power n plus 2r. I have take the power common from these two terms, and it will become 1 upon r factorial, and gamma n plus 1, which is brought here, it will become n factorial. Remember that gamma n plus 1 is equal to n factorial, and this property is also proved in one of our lectures. You can watch it there, and the rest of the terms will be n plus 1 into n plus 2 into n plus 3 up to n plus r. Clear? So now further, remember this term here, this term which I am going to write it, this is actually equal to the n plus r factorial. Clear? This series here, it is equal to n plus r factorial, because you can see that here it is n factorial, and n factorial is from 1 2 3 4 up to n. Clear? 1 multiplied by 2 multiplied by 3 up to n, and then it is increasing n plus 1 into n plus 2 into n plus 3. So this whole term from n factorial up to n plus r is equal to n plus r factorial. So let me write it here, that j nx is equal to summation from r equals to 0 up to infinity minus 1 to the power r into x divided by 2 whole to the power n plus 2r into 1 upon r factorial into this whole series is n plus r factorial. Clear? And also by using this property that n plus 1, gamma n plus 1 is n factorial, then n plus r factorial will be equal to gamma n plus r plus 1. Clear? So it will become summation from r equals to 0 up to infinity minus 1 to the power r into x divided by 2 whole to the power n plus 2r into 1 upon r factorial into gamma n plus r plus 1. Clear? As according to this property, if we have gamma n plus 1, so it gives us n factorial. Similarly, for n plus r plus 1, if we replace here n by n plus r, so it will become n plus r plus 1, which is equal to n plus r pictorial. Clear? So we have replaced n plus r pictorial by gamma n plus r plus 1. And this equation, which is equation number 2, is called Bessel function of order n, Bessel function of first kind, and it is of order n. Here this n represents the order of the Bessel function. Clear? And this is called Bessel function of first kind. Clear? So remember students, when n is equal to 0, this is our result which we have obtained. Now we are going to discuss some cases on the Bessel function of order n. So if n is equal to 0, so it will become j naught of x, and this will become equal to summation from r equals to 0 up to infinity minus 1 to the power r divided by r pictorial. Clear? And this, and similarly this term, which is let me write it after it, and this gamma n plus r plus 1 will become gamma n plus 1, gamma n plus 1, and x divided by 2 to the power 2r. Clear? And gamma n plus 1 is n factorial. Clear? So sorry, this is not n, but this is r plus 1. This is r plus 1, so it will become r factorial. Therefore this will become summation from r equals to 0 up to infinity minus 1 to the power r divided by, this will become r factorial and this is r factorial, this, so it will become r factorial square, and x divided by 2 whole to the power 2r. R, if we expand this series, so it will become 1 minus x square divided by 2 square plus x to the power 4 divided by 2 square into 4 square minus x square divided by 2 square into 4 square into 6 square plus so on. Clear? This is for n is equal to 0. And now if we put n is equal to 1 in this equation, for if n is equal to 1, so it will become j1 of x, which is equal to minus 1 to the power r. This term only gives us the sign, the alternate signs. The first one is positive, the next is negative, and then positive, negative, and it will become x by 2 whole to the power 1 plus 2r. Clear? And it will give us r plus 2. Remember? So I am going to write the whole series. So it can be written as x divided by 2 minus x cube divided by 2 square into 4 plus x to the power 5 upon 2 square into 4 square into 6 and so on. So if we plot these two function, which is for j naught of x and j1 of x, if we plot these two functions, so both the functions are oscillatory with varying period and decreasing amplitude. So I'm going to draw the graph of these two functions. So the graph will become like this one. Clear? So first for the j naught, so if we put x equal to 0 here in this expression, when we put x equals to 0, so it will give us 1. Clear? So the graph will come here. So let me plot the here. These are the values of x: 1 2 3 4 5 6 7 8 9 10 and so on. Clear? So if we put x equals to 0 in this series, so it will give us 1. And for when we are going to put the higher values here, so if we reach up to 2.5, so the function will become 0 here. So I am not good in plotting the functions. So the graph is coming like this one, and for the value of 4, it will give us minus 0.5. Clear? This is minus 0.5, and onward it will become like this one. So if you can see here that the this function j naught x is oscillatory function, and also the period of this function is varying, and also it has decreasing amplitude. And similarly, if we plot this function, so it will give us like this one. For x equals to 0, it will give us 0, and for x equals to 2, the value will become maximum, because this will become positive, and it will reach up to this one. And for x equals to 4, it will become 0. So this one is for j0 of x, and this one is for j1 of x. Clear? So what we got here, that the Bessel functions are the oscillatory functions, and also they have varying period and decreasing amplitude, so you can see it. And so I think the This function is obtained for positive value of n. If we put m is equal to plus n. Similarly, if we put m is equal to minus n, for m is equal to minus n. Similarly, for m is equal to minus n, the same result will be obtained, but it will be like this equation, but n will be replaced by minus n. Clear? So let me write it here as j negative n x is equal to summation from r equals to 0 up to infinity minus 1 to the power r x over 2 whole to the power minus n plus 2r into 1 upon r pictorial into gamma minus n plus r plus 1. Clear? So this is for m is equal to minus n, and this is the particular solution of the Bessel equation, and the general solution is obtained. The general solution of Bessel equation will become like this one, which is y equals to a j nx plus b j minus n x. So it will be the linear superposition of both the function for positive and similarly for negative end, where a and b are some constants. Thank you very much.